The universe is vast, it is ancient, and it is filled with wonders beyond our imagination. We often look up at the night sky and dream of other worlds, perhaps like our own. Gentle breezes, liquid oceans, continents teeming with life, but the cosmos is not always so welcoming. For every potential paradise, there are countless worlds of unimaginable terror. These are not the friendly planets of science fiction. These are real places, confirmed by our telescopes. They are cosmic nightmares, places where the laws of physics conjure up realities that would shatter our senses and annihilate us in an instant. These are the true monsters of the cosmos, lurking in the dark between the stars. Imagine a world where it rains molten glass sideways at thousands of miles per hour. Picture a planet so close to its star that its surface is a sea of boiling lava, a world literally melting under the gaze of its sun. Think of a place so dark it absorbs nearly all the light that falls upon it, a phantom planet drifting through space. These aren't fantasies, they are destinations on our ever-expanding cosmic map. So, prepare yourself. We are about to embark on a voyage to the most terrifying, deadly, and utterly alien worlds in our galaxy. For most of human history, the only planets we knew were the ones in our own cosmic neighborhood. Mercury, Venus, Mars, the gas giants. They seemed like a complete family, but we were looking at just one household on a street of billions. In recent decades, our view has exploded. We've discovered that our sun is not unique in having a planetary system. In fact, most stars do. The planets orbiting other stars are called exoplanets, and we have found thousands of them. It's a staggering realization. Our galaxy could be home to trillions of worlds. When a planet passes in front of its star, it causes a tiny dip in the star's light. By measuring that dip, we can determine the planet's size. By observing the wobble of a star, we can calculate the planet's mass. And by analyzing the starlight that passes through a planet's atmosphere, we can even figure out what it's made of. This is the science of remote exploration. We are cosmic detectives, piecing together clues to paint a picture of these distant alien worlds. What we found is a zoo of planetary oddities. Hot Jupiters, gas giants orbiting so close to their stars that their years last only a few days. Super-Earths, rocky planets much larger than our own with crushing gravity. Rogue planets, cast out from their star systems to wander alone in the cold black emptiness of interstellar space. Let's take our ship of the imagination to our first destination. It's a planet just 63 light-years away. From a distance it looks beautiful, a deep azure blue reminiscent of our own Earth. You might be tempted to call it an ocean world, a tranquil twin to our home, but that beauty is a deadly illusion. This is planet HD 1897-33b, and it is one of the most terrifying weather systems we have ever discovered. The lovely blue color doesn't come from reflected light off deep oceans. It comes from an atmosphere laced with silicate particles, the building blocks of glass. This planet is a hot Jupiter, a gas giant orbiting perilously close to its star. How close? It completes a full orbit 1 year in just 2.2 Earth days. This proximity cooks the planet to a blistering 1,000 degrees Celsius, or about 1,800 degrees Fahrenheit. At these temperatures, the silicate particles in its atmosphere don't form gentle clouds, they melt into droplets of molten glass. So yes, on this world, it rains glass. But that is not even the most terrifying part of its weather forecast. This planet is a world of unimaginable winds. Because the planet is tidally locked, one side always faces its star, creating a permanent, scorching day side, while the other is locked in eternal night. This massive temperature difference drives winds of incredible speed. How fast? Scientists have clocked them at over 8,700 kilometers per hour, or about 5,400 miles per hour. That's more than 7 times the speed of sound. Our next stop takes us 400 light-years away to a planet that redefines the meaning of extreme heat. Meet Kepler 78b. This world is roughly the size of Earth and has a similar density, suggesting it's a rocky planet much like our own. But that is where the similarities end. Kepler 78b orbits its star at a distance that is almost incomprehensible. It is 40 times closer to its star than Mercury is to our Sun. Its orbit is so tight, so fast, that its year lasts a mere 8.5 hours. You would celebrate a new year every single workday. This extreme proximity has catastrophic consequences. Surface temperature is estimated between 2,000 and 2,800 degrees Celsius, about 3,600 to 5,000 degrees Fahrenheit. Rock on Earth melts at around 1,200 degrees Celsius. The entire surface is a permanent roiling ocean of molten rock, a global sea of lava. Any mountains it once had have long since melted away into this fiery soup. It's a planet perpetually in the process of dissolving. How could a human possibly survive here? The answer is simple. You couldn't, not even for a nanosecond. Before you could even register the view, you would be vaporized. The heat would break down your body into its constituent atoms instantly. From the inferno, we now travel to the opposite extreme. Let's journey 20,000 light-years toward the dense center of our Milky Way galaxy. Here we find one of the coldest exoplanets ever discovered. Its name is Ogle 2005 BLG 390 pounds, but astronomers call it Hoth. A rocky world about 5 times the mass of Earth, trapped in an eternal deep freeze. It orbits a red dwarf, much smaller and cooler than our Sun. It sits far from that dim star, roughly the distance from Jupiter to our Sun. The result? Almost no warmth. Surface temperature, minus 220 degrees Celsius, that's minus 364 degrees Fahrenheit. Just 50 degrees above absolute zero, where atomic motion nearly stops. A cold beyond easy comprehension. Familiar substances act in alien ways. Any atmosphere would have frozen and fallen as snow, nitrogen ice, oxygen ice, water frozen solid, carbon dioxide frozen solid, methane frozen solid, a static, silent wasteland of exotic ices beneath a dim red sun with almost no light or heat. Let's return to the realm of fire, to a planet that combines some of the worst features we've seen so far. Meet Coro 7b, located about 489 light-years from Earth. One of the first rocky exoplanets discovered quickly revealed it was no Earth twin. It orbits incredibly close to its star, completing a full revolution in just 20 hours. The day side is cooked to over 2,500 degrees Celsius, about 4,500 degrees Fahrenheit. But Coro 7b has a terrifying twist. It's tidally locked. One hemisphere is a permanent ocean of lava. That heat vaporizes rock, creating a thin atmosphere of rock vapor. Think of it like water vapor on Earth, but the air is filled with vaporized minerals, silicon, iron, magnesium. Those rock vapors form clouds, not white clouds, but vaporized stone. The clouds drift to the cooler night side. When hot vapor meets cooler air, it condenses. It rains. On Earth, vapor makes water. On Coro 7b, it makes droplets of liquid rock, magma. These droplets fall as a pebble-like rain. So yes, it literally rains rocks. Now let's journey to a place defined not by what it has, but by what it lacks. We travel 750 light-years to the planet Tres 2b. This is a gas giant, similar in size to Jupiter, but it is a world of profound and unsettling darkness. We call it the dark planet for a very good reason. It is the darkest exoplanet ever discovered. It reflects less than 1% of the starlight that falls upon it. To put that in perspective, fresh asphalt reflects about 4% of light. This planet is literally darker than a lump of coal. Why is it so dark? Scientists are still piecing together the puzzle, but the leading theory points to its atmosphere. Tres 2b is another hot Jupiter with temperatures around 980 degrees Celsius, about 1,800 degrees Fahrenheit. At these temperatures, clouds like the ones on Jupiter, which are made of reflective ammonia ice, cannot form. Instead, its atmosphere is likely filled with light-absorbing chemicals. Exotic substances like vaporized sodium, potassium, or titanium oxide could be acting like a planetary-scale sponge, soaking up almost all visible light. Imagine floating in the upper atmosphere of this world. You would be enveloped in an oppressive, inky blackness. Even though you are incredibly close to a bright star, the sky around you would be almost completely dark. Our final destination is perhaps the most unsettling of all. We journey to a place of death and rebirth, 2,300 light-years away. Here orbits a star that should not have planets. This is a pulsar, designated PSR-B, 1257 plus 12. A pulsar is the rapidly spinning superdense corpse of a massive star that died in a supernova explosion. It's a cosmic zombie, a dead star blasting out beams of intense radiation like a deranged lighthouse. Against all odds, planets orbit this stellar corpse. These were among the very first exoplanets ever discovered. They are truly bizarre. Nicknamed Poltergeist, Phobator, Draugr, they are rocky worlds. They live in an environment of unimaginable hostility. The pulsar sweeps beams of lethal radiation across their surfaces with every rotation. This is not gentle sunlight, it is a high-energy blast that would strip away any atmosphere and sterilize any surface. These worlds are constantly irradiated, bathed in energies that would obliterate any form of life as we know it. The very existence of these pulsar planets is a profound riddle. How did they get there? They couldn't have survived the supernova that created the pulsar. The leading theory is grim. Second-generation planets formed from the dead star's debris. Zombie worlds in the truest sense. They orbit a dead star and are made from its remains. Life could never arise here. These planets are a chilling reminder that even after a star dies, its story isn't over.